Alright guys, sorry about that. Like I said, I had class coming in, so I needed to pause the video. So we're going to pick up where we left off on exercise 6. Alright, so looking at exercise 6, I know that 72 is not a perfect square. So therefore, I am going to see what I can do with this. I want to see if I can break it down. Alright, so when I break it down, I want to try to break it down into something that is a perfect square. So the square root of 72 can be the same thing as the square root of 36 times the square root of 2. Alright, so now I can look at the square root of 36, which is 6, times the square root of 2. So my answer is 6 square root of 2. Alright, looking at the next one, number 7. The next thing, square root of 17/25. I can divide this into 2 parts. The square root of 17 over the square root of 25. The square root of 17, thinking about this, really there's nothing I can do with it because 17 is a prime number, meaning the only 2 factors are 17 and 1. So I can't break that up, but I can take the square root of 25, and that would be 5. Alright, square root of 32x. Alright, so let's look at that. 32 is not a perfect square. So I'm going to see if I can break that up. 32, so I want to see if I can come up with a perfect square. So 4 can go into 32, but if I can go something bigger, let's see if I can do that. So 4, 9 won't go into it. 16 will go into it. 16 times 2 is 32. So I'm going to make this the square root of 16 times the square root of 2x. Alright, now let's take the square root of 16. So I get 4 times the square root of 2x. I can't do anything with that. So my answer is 4 square root of 2. Looking at number 9, square root of 1/3. Alright. So I'm going to break it up. Now with this one, there's not anything I can do with this, so I want to find an equivalent radicand that I had just like we did here. Alright, so I'm going to multiply both sides by square root of 3. So the square root of 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 is the square root of 9. So looking at this, the square root of 3 I can't do anything with because 3 is prime. And the square root of 9, that is 3. And there's my answer. Okay. Alright, let's look at number 10. The square root of 54x squared. With this one, I can break it up. I'm going to go ahead and break 54 up. I can break that into the square root of 9 times the square root of 6 times the square root of x squared. Alright, so now let's go ahead and reduce this as much as I can. The square root of 9 is 3. The square root of 6, guys, 2 and 3 are the only 2 numbers I can break this into. Neither one of those are perfect squares, so I'm just going to leave the square root of 6 the same. And then the square root of x squared is x. So my answer is 3x times the square root of 6. Number 11, they've already broken this one up for us. So here's what I'm going to do. I actually want to put it back together. Because look at this. If I make this a square root of 36 over 18, 36 divided by 18 is 2. So I end up with the square root of 2. And it's as simple as that. All right? Let's look at number 12. Square root of 4 over x to the 4th. In this case, I'm going to go ahead and split it up. Square root of 4 over the square root of x to the 4th. What is the square root of 4? That is 2. And the square root of x to the 4th, what times itself gives me x to the 4th? That would be x squared. So my answer is 2 over x squared. Look at number 13. Notice only one part is under the radical sign. All right, so let's go ahead and look at this. So I have 4x. The square root of 64 is 8. 8 times 8 is 64. And the square root of x squared is x. Now I can reduce this because 4 over 8 reduces to 1 over 2. And x divided by x is 1. So my answer here is 1/2. All right, 5 over the square root of x to the 7th. Well, in this case, there's nothing I can do with the with the 5. So, sorry guys, I lost train of thought there for just a second. I want to look at x to the 7th. Guys, remember when you multiply exponents, you actually add their exponents. So, I want to know what times itself can give me x to the 7th. Well, nothing can. But let's look at what happens if I do this. Now I have 5 square root of x times square root of x to the 8th. I cannot take the square root of x, so I'm going to leave it. But then the square root of x to the 8th, so x to the 4th times x to the 4th gives me x to the 8th. All right, look at number 15. The square root of x fifth over 2. All right, so let's break that up. X to the 5th over the square root of x, or over the square root of 2. All right, let's go ahead. I actually can simplify this because I can break this into x to the 4th and x. So that would be x squared times the square root of x over the square root of 2. I do not want a square root in the bottom, so I'm going to multiply it times the square root of 2. Alright, so when I do that, I get x squared, and then square root of 2 times the square root of x is the square root of 2x. Square root of 2 times the square root of 2 is 2. Alright, and number 16. The square root of 18x over the 3 square root of x to the 5th. Let's go ahead and look at this. And let's see what I can do. I can break the square root of 18x into the square root of 9 times the square root of 2x. And then I'm going to come down here, and I can't do anything with the 3 just yet. X to the 5th, I can look at that as x to the 4th times x. X to the 4th would be x squared times the square root of x. All right. So let's simplify this as much as I can. Square root of 9 is 3. Square root of 2x. 3 over x squared. Square root of x. All right. Simplify that even more. 3 divided by 3 is 1. So I get square root of 2x over x squared square root of x. I cannot have a denominator with the square root in it, so I've got to do the square root of x. Alright, so I get square root of 2x times x is the square root, the square root of 2x squared. And then I get x squared, square root of x squared. Alright, so let's come down here and let's look at this for a second because there's some things I can do here. I cannot take the square root of 2, but I can take the square root of x squared. Alright? So x squared would be x. So this is x square root of 2 over square root of x squared is x. So x squared times x is x to the third. And now I can reduce my x's. So if I have x over x times x times x, x divided by x is 1. I actually have 2 x's on the bottom. So I have square root of 2 over x squared. Alright? So that one took just a little bit of time. Alright, let's look at the last question. The captain of a ship recorded the ship's coordinates, then sailed north and then west, and then recorded a new coordinate. The coordinates were used to calculate the distance they traveled, square root of 578 kilometers. When the captain asked how far they traveled, the navigator said about 24 kilometers. Is the navigator correct? Under what conditions might we need to be more precise in his answer? Okay, so let's think about 578. So here's what I want to look at. 25 times 25 is 625. That's too much. 24 times 24 is 576. So the square root of 578 is close to the square root of 576. All right? The square root of 576 is equal to 24. Therefore, the navigator is correct in his estimate. Because he said it is about 24. Okay? So it says, when I simplify this, I can look at this as the square root of 289 times 2, or times the square root of 2. So we'll just break it up. Because 289 times 2 gives me 578. 289 squared, or square root of 289, is 17. So I have 17 times the square root of 2. So if I look at this, the square root of 2 times 17 gives me 24.041629, which is about 24. All right? A more precise answer, when would that be needed, is if they were looking for a particular location. They want to know exactly where they're at. All right, guys, that's the end of the lesson. Hope you have a great rest of the week. And I will talk to you next week.